Hi, everyone. Just one thing I was going to point out, Smart actually has two markets that we're focusing on. So there's a business segment and there is an education segment. And I'm mainly going to talk about the education software side of the business in this presentation. So Smart introduced the world's first interactive whiteboard in 1991. And we remain the global product category leader, providing easy-to-use integrated products and services that improve the way the world works and learns. While our product offering started in interactive whiteboards, it has evolved significantly beyond that to include other interactive products, such as interactive displays, interactive tables, interactive pen displays, student response systems, wireless slates, and document cameras, to name a few. Just to sort of give you an idea of what we do at Smart and how some of our products work, I have a short little video demonstrating our SB8 multi-touch board. I'll just switch over here.
The moment you put the world at the fingertips of students, that's when learning accelerates. Students find new ways to explore concepts. They make new discoveries and learn from each other. Here, learning comes naturally, however they do it best. Teachers will say, it multiplies the potential for collaborative learning. They'll say it helps students make deeper connections with content. Students will say, it's awesome.
So that was just an example of our new multi-touch board there. So Smart employs about 260 people in their product development department. This includes firmware, electrical and mechanical engineers, industrial designers, project managers, user experience specialists, and approximately 160 software engineers. We actively work on about 40 projects at any given time, which span Mac, Windows, iOS, Linux, and embedded Windows environments. Because we are a hardware and software company, we have a lot of tight integration between our hardware and software. And we are primarily a C++ shop with about 90% of our software written in C++. So as you can imagine, the challenges that Smart faces are not that different from any other global company. We find that we have to support multiple operating systems that get updated regularly. And on top of that, we also need to support a variety of languages. We actually support over 55 different languages in our products. As you can imagine, our customers' expectations are fairly high that the features that we deliver on our products are the same across all platforms, and that we release them at the same time. As you can imagine, this puts a considerable strain on development and a strain on resources trying to be able to deliver on all three of these platforms at the same time. So ultimately, what we wanted to do was avoid duplicating effort by re-implementing these features on various OSs. This is where we started to evaluate Qt as a solution. We actually started looking at Qt in about 2006. We were looking to increase our product spread without dramatically increasing our costs. We initially started out with just one license, and we developed a few diagnostic tools for our boards that were working on all three platforms. Based on this success, we decided to look into using Qt in one of our main application programs. Specifically, we were looking into supporting Linux with our notebook software. So we actually went ahead and did an initial port of Notebook to Linux. We found that when we finished the Linux port, we were actually able to compare that with an equivalent port that we did of the notebook software to Mac. And we discovered that it took about 1/3 of the time to port to Linux than it took to port to Mac. With this success, we've been steadily increasing our use of Qt throughout the product development area. We now have a total of 75 developer licenses, and we're developing for all three platforms with them. So what was the attraction about Qt? What made us decide that Qt was our solution for cross-platform development? I think there was a lot of reasons when we look back at what Qt offered at that time. Specifically, the excellent documentation. I think if you were at the keynote today, he mentioned that the documentation was quite good. I'm finding that a lot of cases we don't really need much more help than what's available in the documentation. Another thing that has happened over the course of the Qt 4.0 lifetime is the feature set kept getting more rich and expanding. And as we'll talk about with some of the examples of where we've used Qt within the organization, you can see that some of those features that they've added along the way have helped us with some of our development. Another major thing was it's written in C++. As I said, we're a 90% C++ code base, so this makes it almost a no-brainer to be able to use for us. One thing that you may or may not have heard about Qt was the idea of this write once, compile everywhere kind of motto. So we've really found that to be true, where we can actually develop on one platform and then compile on another platform and have it work out of the box. Other things that were important was the fact that we now have one set of APIs to learn instead of three. This really eases the transition from one platform to another, since we no longer need a Windows developer and a Mac developer. We just have a developer that we can transition across the different platforms to work on our products. I mean, even with that being said, there's always going to be some platform-specific requirements, but we found that it's mostly hidden behind the Qt APIs. Another important aspect was the support. We had bought commercial licenses, and we found that having the support of a company behind the product is really valuable when you have a a particular critical issue that you're trying to figure out or you want to know, and you can actually turn to an expert. In a lot of cases, we would get a response within a few days. Even better responses, we'd also get a patch to fix our problem. So we found that to be great. I mean, you can understand with some other open source projects, you're usually relegated to maybe trying the mailing list or seeing what's out there. But with support, you definitely have somebody to back you up. As I've mentioned before, internationalization is a big thing for us, and Qt supports all of our requirements, including right-to-left languages. I mean, I've kind of talked about this point before, but feature parity was really one of our key requirements to being able to use or evaluating a toolkit that we could use across platforms. Specifically, when I talk about the Linux port, we were concerned about being able to have functionality equivalent to GDI+, which is the Windows drawing API. At that time, the only widget set that we found that offered that ability was Qt. So this allowed us to deliver a product on Linux with the equivalent functionality. I don't know if this is mentioned a lot, but actually having access to the source code is very valuable as well. There's a lot of times where you may run into some platform differences or some maybe what you think is a bug in the code, but actually being able to look under the hood and see what is going on in the implementation has allowed us to work through a lot of problems. And in some cases, we can even generate our own patches to fix issues specific for our products. So in summary for us, Qt really continues to grow with us, and as our needs have changed, so did Qt. Specific examples that I'm going to cover in this talk are the use of QStyleSheets, Qt WebKit, and then a bit of talk about multi-threading with QThreads and signals and slots. So as our first example, I'm going to talk about QStyleSheet. So what's interesting about QStyleSheet is that it offers a very powerful mechanism for styling your user interfaces. What's interesting for us is, although Qt is kind of known for being able to provide that native look and feel on each platform that it's on, sometimes there's a case where you actually want your application to look the same across all platforms. We have several applications dealing with administration and product update that we really want a unified look. And QStyleSheets kind of gives you a way to do that. So what's nice about QStyleSheet is it's very similar to the CSS standard. So things such as borders, margins, gradient styling are all available, and they work almost exactly the same as CSS. So what this allows us to do is give a graphic designer the QCSS file, and they can actually style it with the correct gradients and pixel heights and stuff like that, and then we can give it back to the developer, who can then write the underlying logic. So this kind of gets you away from the questions where I know for many developers, kind of what happens with the graphic designer is they give you this beautiful picture of the interface, and it's got all these exact pixel sizes and stuff like that, and then you're kind of left up to yourself to recode this in MFC or Cocoa. And you usually have questions like, how many pixels wide should that button be? What colors are those gradients? And using QStyleSheet kind of really eliminates a lot of this, because the designer can effectively make those changes themselves. So the other nice thing about the style sheets is that it allows you to tie directly to the widget types, the widget classes, and the subclasses. So you can actually style individual bits of elements of the interface. So you can also give names to particular elements within the interface, this allows you to group those styles into various functions. So depending on what's happening in your program, you can actually change the entire style based on a function rather than a logical grouping in the interface. So ultimately what we found because of using QStyleSheet and QSS, we could actually take the turnaround time from design to implementation of a lot of the interfaces down from days to hours, which it can really be that quick. And the other nice thing was, because it was all implemented in Qt, it was consistent across all platforms, and we could just develop on one space. The designer could use whatever they were most comfortable with, Mac or Windows, and we got a nice result from that. So another example I was going to look at was the use of Qt WebKit. So Qt WebKit actually was a module that became supported during the Qt 4.0 series. And it's interesting now that everything's kind of moving to this hybrid web or web services type of integration. And recently we've started to look at trying to integrate browser type functionality into some of our products. So we were looking around probably about late 2010. We were looking just for an embedded web browser solution. We evaluated various platforms. We were looking mainly at Gecko and WebKit-based solutions. But unfortunately, Mozilla discontinued their embedded browser support, so that was no longer an option for us. We started to look a little closely at WebKit. What we found was it was easy to embed, but the code was very platform specific. So what I mean by this is the way WebKit works is each version of WebKit has a specific platform port, which usually uses the native APIs to render the WebKit view. And what we found with a lot of the WebKit ports is also that the API that was exposed, because every WebKit port can expose their own WebKit API that can be used on their platform, assume that you wanted a Windows-based solution, basically meaning that it was always within a container view. What we really needed was a headless WebKit, so one that you could render to without actually having to display a window. And we needed this to seamlessly integrate into our software. So after looking at several different WebKit ports, what we noticed about Qt WebKit was there was an API called QWebPage, which really gave us something that solved all of our needs. For one, it was a headless web page. We could also feed it our own events, and we could render a page to an image, which could be used anywhere that we needed it to be, such as thumbnails, previews on our whiteboard for our application. So suddenly, a lot more things were possible. In fact, now we actually have been able to integrate it into our product, and we're actually working on a WebKit API. You can kind of think of it as widgets for your desktop kind of thing. So we'll actually be able to ship little widgets based on HTML5 and JavaScript that can interact with our application. So for us, it's like we can now have like a little store of little apps that teachers can download to enhance their lesson plans. So we've been very pleased with the result. We can now handle HTML5 with Qt 4.72. All of the scroll bars and controls inside of the browser look native and act correctly on Mac and Windows, which is actually a big thing for our users. There's a single code base. We were able to use one graphics API to share within our application that easily integrated with the native graphic applications. And it was easy to make changes to the code. We actually had to make a few patches to get everything to work correctly, but we found that the quality of code was fairly high, so it was easy to discover where we needed to look and what we needed to do. And as a bonus, we were able to use a lot of the extra features of Qt as well, based on having the full framework there. We implemented a basic out-of-process model for our web browser. You can think of this as very similar to how the Chrome browser works right now, Google Chrome. And we actually did it we had a prototype available in about under a week with just one developer. And this worked out of the box on Mac and Windows for us. So last thing I'm going to talk about is about QThread. And it's mainly more about the multi-threading capabilities within Qt. For us, because we are a software and hardware company, we have a lot of protocols that we use for communication with hardware. And a lot of this requires a state machine to coordinate the command flow. So often our software will need to run one thread to maintain the state machine and run a second thread to receive events and to communicate with the interface. So because when you're updating firmware, the flow of these events is very vital to keep synchronized, we were able to use a lot of the cross-thread communication set up within Qt for us. So specifically, we're talking about using signals and slots across threads. What we found is, if you're familiar with Windows and Unix-based operating systems, a lot of the threading can be quite different between the platforms. But Qt provides just one API that we can use with a few simple lines of code that's easy for other developers to come and understand afterwards. That really benefited us. So there was a lot of reduction in complexity around multi-threading and handling threads. And it really led to a little bit of code that does a simple thing well. So it's also been easy to maintain just because it's easy to understand as well. So in summary, over the last few years, we've grown from 1 license to 75 Qt license. We have over 30 applications that are based on Qt as of today. As I've mentioned before, it's increased our capacity, being as we can now have 1 developer for 3 platforms rather than 3 developers on 3 platforms. It also means that we can focus on writing features instead of porting features to other platforms. It also means that it's easier for us to deliver all of our products on all platforms at the same time. So I'd say we'd roughly received probably about a 50% reduction in development time, as I've mentioned, which has really helped us to keep parity and release alignment across platforms. So Qt has provided a solution which we can trust, and that we will maintain consistency across all platforms with 1 code base. Once again, this write once, compile everywhere, that we've kind of found to have been true. So that's all I have for today. Is there any questions?
Just actually one technical question about how you develop the user interface. What's the methodology? Both of my children actually use your products, so I've had some experience with them, and I was just curious how you do that.
Well, essentially we have a a group called the user experience group. So they actually go through and make recommendations on how we should design the interface. And then we actually go through a series of user testing. So we actually bring in teachers and students and get them to evaluate our designs before we finalize them. Is that kind of what you were looking for? Or? Yeah. So yeah, there's a lot of thought that goes into trying to figure out what students want, what teachers like, and making that easy to use.